All right, greetings everyone. Welcome to the fourth part of the video for section 5.1. Continuing on with our studies of circles and the equations of circles and different applications of that equation. Now, before we get into the math, I just have to say that this meme right here is one of my favorite I've ever found. It does make me chuckle quite a bit. You may not find it as funny. Maybe it's just funny to me because I'm the teacher. And you know, that's really what's most important with picking these, is what's funny to me. So, you know, just wanted to throw that in there. All right, let's do some more algebra with the equation of a circle. So in this problem, we're asked to find the intersection of x squared plus y squared equals 18 and y equals 6 minus x. Now let's think visually about what we're talking about here in a coordinate plane. So first of all, it's a coordinate plane. This x squared plus y squared equals 18. Hopefully you would agree with me that's the equation of a circle centered at 0, 0. So that may be something like this. And then what would the y equals 6 minus x? What would that be? To think back to PreCalc 1 or whichever course you took before this one. All right, that would be the equation of a line. So that would probably look something like this. Okay. And notice if we're trying to find the intersection here, well, in this case, the way I've drawn this, it looks like we could have 2 points of intersection, right? But you might also think about there are other possibilities, right? We could have something where, say, the line intersects the circle like this, which then we see that the intersection point is only a single point. Or there is a possibility we could have something like this, right, where the circle and the line don't intersect at all. So hopefully we'll be able to figure that out as we work through this. Now, in this case, unlike the previous two examples we've done on stuff like this, we're not given a value for x or y. So how are we going to deal with that? Well, notice in the second equation we have, the y equals 6 minus x, we're actually given something for the value of y, right? Notice that it's not a number, but it's something, right? We're told that y equals this. So that tells me we could probably take that thing that y is equal to and plug it in for y over here in our equation. So let's see what happens when we do that. So once we do, we have x squared plus, plug it in for y now, we have 6 minus x squared. So that value, again, 6 minus x is taking the place of the y, equals 18. And notice this is beneficial for us because now we have the values, or we have our equation in terms of only a single variable, which is x. So we can go through and solve this now. So how are we going to do that? Well, unfortunately in this case, we can't deal with the 6 minus x in parentheses being squared, primarily because we have an x outside of the parentheses. So we need to get rid of those. And recall that when we do something like 6 minus x quantity squared, that is not just equal to 6 squared minus x squared. We cannot just distribute the exponent there. Okay, this is no good. Recall that when you square something, that means to multiply it by itself, right? So if we have 6 minus x times 6 minus x, or 6 minus x squared means to do 6 minus x times 6 minus x. And then we can go ahead and use FOIL to work that out. And so I'm just going to do that. If we do, I believe in this case we'll end up with 36 minus 12x plus x squared. And you can double check my work on that. Okay. So up here, what that's going to give us for our equation now is we'll have x squared plus 36 minus 12x plus x squared equals 18. And then on the left-hand side there, we have some common, or some like terms that we can combine. So I believe if we do that, we see we have the x squared and the x squared. So that become 2x squared. Just the minus 12x there, and then the plus 36 equals 18. And now, even though this might look kind of complex still, notice we are in business to get some stuff done here. So first things first, notice that this equation is a quadratic. Okay, and we know that because the highest power of the variable is a 2. So we know that, first of all, when we're solving quadratics, we need to make them equal to 0. So in order to do that, I'm going to move the 18 over to the left-hand side by subtracting 18 from both sides. This becomes 2x squared minus 12x plus 18 equals 0. And at this point, we have a couple of different options for how we can proceed. First of all, note that, again, this is a quadratic equal to 0. So one of our options for solving this would be our good friend, the quadratic formula. Okay, and if you need to look back at your notes from PreCalc 1 or previous math class or on the internet for what that means, you can do that. Or another approach here would be to do some factoring. And so I'm going to go with that approach, because first thing I notice is that every one of my coefficients here on the left-hand side is divisible by 2. So that means I can actually factor out a 2 here. So this becomes 2 times, and when I factor it out of each term, I'll end up with x squared minus 6x plus 9 equals 0. And notice now I can divide away that 2 by dividing by 2 on both sides. And when we do that now, we end up with x squared minus 6x plus 9 equals 0. And then this x squared minus 6x plus 9, we can actually factor that, so kind of do the opposite of the foiling that we did before. And recall that when we factor, we find two numbers that will add to this middle term, so negative 6, and multiply to this final term, which is positive 9. I think that those two numbers in this case would be minus 3 and minus 3. So it looks like I end up with x minus 3 times x minus 3 equals 0. Again, if we check that, notice that minus 3 gives us a negative 6. Negative 3 times negative 3 gives us a positive 9, so that works. And then recall that to finish this, we can take each of those terms, or each of those factors, the x minus 3 and the x minus 3, and set them equal to 0, and solve. And then hopefully you would agree with me that in each case, we're going to get x equals 3. Okay, and in fact, in this case, we end up with just one answer, right? Even though we'd end up with 3 twice, we still get 3 in both cases. So that would be our value for x. All right, now big question. Are we finished? Hopefully your answer is no, right? Because we're trying to find the intersection, and really this should say an intersection point between this line and this circle. So now that we have the value for x, we need to find the value for y. And the most straightforward way to do that, I think, would be to take this value for x, plug it in here in the equation for y. So we do y equals 6 minus the value for x, which is 3. So that gives us y is 3. And so putting those together gives us that our intersection point here is 3, 3. Okay, and there we go. And now we're done. Wasn't that fun? Yeah, I agree. Now, a couple of things I want to point out about this. Now, number one, when you have a problem of this type, your answers will not always come out as nice as they did here. So we got nice round whole numbers. So that will not always happen. In fact, I would say most of the time that will not happen. The other thing is notice again here I ended up with just one answer. So for the values for x here, we just got 1. And again, I would say more often than not, you're going to get 2 answers there, which means you should have 2 different points of intersection between the circle and the line. So you need to find both of those points once you have your values for x. Okay? All right, that's all for now. Thank you for watching.